All right, so quick introduction of myself. I'm Ajay. I run partner engineering at Databricks. I'm going to spend next 10 minutes walking you through Azure Databricks, and specifically inside of Databricks, the latest innovation around Delta Lakes. And then the last 10 minutes, we're going to spend actually demoing the system to you guys, and my colleague Bhavin over here is going to do the demo. Now, before I get started with the session, how many of you guys have heard about Databricks before, by show of hand? That's awesome. Thank you. And I should also express my thanks for you guys to show up at this session. This is the last session of the day. I really appreciate it. So let's get started over here. Just a quick word about Databricks. So Databricks today is a global, it's a global company. We have over 5,000 customers. We have over 1,000 employees. We are present in US. We are present in EMEA, and we are present in APAC. Yeah. What we have to offer in the market is really a unified analytics platform that allows enterprises to innovate and drive data-driven insights by bringing together data scientists, data engineers, and the business teams together on a common consolidated platform. Okay, so that's Databricks. Databricks was founded in 2013, and so we have been in the market for about 5-6 years now. Now, one of the things that you probably know about Databricks is that Databricks was started by the original creators of Apache Spark, right? Apache Spark was created at UC Berkeley in 2008 by the founders of Databricks. And since then, we have continued on the path of innovation. So we have since then created new open source initiatives, right? The two latest of which, the two latest is the Delta Lake initiative and the MLflow initiative, okay? And in the session today, I will really be focusing on the Delta Lake initiative. If you guys want to follow up on what's going on with MLflow, just catch up after the session and or show up at our booth. Now, what is Azure Databricks? So Databricks offers a unified analytics platform for driving data insights, right? Azure Databricks is an offering of Databricks on Azure, right? So it is built in collaboration with Microsoft. We have a very strong engineering relationship with Microsoft and a go-to-market and support relationship with Microsoft, right? So users of Azure Databricks are customers of Microsoft, right? You get the first-party service with the backing of the engineering might of Databricks behind it. Yeah, so you really get the best of both worlds. You get the reliability, the security, the scalability, the support, the single contract of Microsoft, and you get the engineering might of Databricks behind the service. Now, as you think about Azure Databricks within the Azure ecosystem, it's really important for any service, including Azure Databricks, to be very tightly integrated with the rest of Azure ecosystem, right? Because no one single tool is an end on its own. Typically, your solution involves combining multiple of these tools into an end-to-end solution, right? So Azure, as Databricks and as Azure Databricks in collaboration with Microsoft, we make sure that Azure Databricks is very tightly integrated into the rest of the Azure ecosystem, right? That includes integrating with the data storage systems like data lakes, right? Cosmos DB, SQL Data Warehouse. That means integrating with the security portfolio of Azure, right? That's Azure Active Directory, that's following Azure Active Directory permissions, conditional access, all of that is supported within Azure Databricks. And that also means being very tightly connected to the consumption services from Azure, such as Power BI and SQL Data Warehouse, right? So a lot of what we do on Azure Databricks is making sure that Azure Databricks is very tightly integrated into the rest of the Azure ecosystem so our customers can build and enable that end-to-end solution. Okay, now the next thing I really want to talk about, and the focus of this presentation is really Delta Lake. So what is Delta Lake? It really is bringing reliability and consistency and performance to enterprise data lakes. Okay, now how many of you guys have heard about data lakes before? Yeah, we have all heard about data lakes. Yeah, data lakes has been a buzzword in the market for at least last 6 years, if not more, right? And why did data lake become so popular, right? Why was the emergence of the word data lake? if you look at any executive, right, all of us, I'm sure, as we walk the hallways of our enterprise, there are two things we hear about. We hear about digital transformation, right? And we hear about being data-driven, right? Being a data-driven enterprise, okay? What is digital transformation in the end of the day? It's enabling digital services to improve customer experience and to improve your internal efficiencies, right? What does that initiative do? It creates more data. It creates more data that you can analyze to improve your offerings in the market, to improve the customer experience, right? And being data-driven means what? Being able to analyze all your data so as to be able to gain insight from it, right? So neither one of these on its own is a new concept. Yeah? They have been around for at least a decade now, digital transformation and being data-driven. So how have enterprises gone about enabling being data-driven and being enabling digital transformation is by creating data lakes, right? They have been collecting all data that is generated within their enterprises into data lakes, okay? The reason why they did data lakes is because one, it gives you a very economical way to store all your data, and two, because it is extremely flexible. It doesn't require you to have a fixed schema or impose a schema right up front, right? So there are lots of advantages to data lake and why enterprises have adopted data lake to create a collection of all their enterprise data. Now, with the advantages of data lake, what we observe with our customers in the cloud is that the data lake had some deficiencies. While it gave you tons of flexibility around schema, it gave you immense flexibility with cost, right? Compared to other data systems, it also had reliability and performance issues, right? So Delta Lake really addresses the deficiencies of data lakes by bringing reliability and bringing performance while giving enterprises the same benefits of cost and flexibility that was offered by traditional data lakes. Does that make sense? Yeah? So let's just look into what is Delta Lake at the next level detail. So what you see on this slide is really some of the problems that people ran into with data lakes, right? In the world of data lakes, if a job failed, and whether that was a Spark job or another MapReduce job, your data could end up in a corrupt state, right? There was no transactional guarantees with data lakes, okay? And so what we saw with our customers who were building Spark applications on traditional data lakes is occasionally they were ending up with inconsistent data, right? Which obviously is a very bad situation to end up in. The second problem that we observe with our customers is that they didn't have any control over schema. There was no system to enforce any schema. And yes, you want your initial landing zone to be very flexible, to be able to incorporate all different types of data. But as you progress your data and as you refine and curate your data, you want to start imposing schema on it so you can then do consistent analytics on top of it. And traditional data lakes did not have any schema enforcement on it. Right? And then lastly, what we saw was lack of consistency. So if you're reading data into your data from a data lake while you're writing to it, you will end up getting inconsistent results, right? So you had to really build your pipelines to be sequential. You could really not build parallel pipelines reading and writing off the same data lakes because they will end up reading half the data and you will end up with essentially inconsistent results and the analysis, right? So those were issues that our customers faced using data lake from a reliability perspective. And then from a performance perspective, again, if you guys have been using data lake in the past, you probably have run into this problem, which is too many small files, right? If you, especially in a streaming world where events are coming one at a time and you want to do real-time processing of it, you end up with a data lake that has lots of tiny files inside of it. Yeah, and that has a very severe impact on the performance of your data lake. Okay, so our customers were running into many small file issues. There was no proper indexing scheme within your data lakes. You could partition your data, you could create folders, subfolders, but that was really poor man's indexing. Yeah, if you have come from the database world, you have been used to creating indexes on any column, any combination of columns, right? And you couldn't do that on data lakes because there was no real indexing scheme other than to create some poor man partitioning within your data lakes. And finally, there was no real way for you to cache data within data lakes, and that led to performance challenges as well. So combining as we work with our customers in the cloud with data lakes, we observed our customers struggling with the reliability and performance of their data lakes, right? Which led us to really innovate and create what we call the Delta Lake now. Okay, so what is Delta Lake? So Delta Lake is a new standard for building data lakes. Okay, one common question I get is this proprietary? So no, just like everything we do at Databricks, this is an open source technology. So we have created it and we have donated it to the Linux Foundation. Okay, so it is open standards, it is open format. So it is essentially Parquet files. Okay, on your and sitting on your in the same blob store that you have always been using for your data lakes. Okay, what it does, it brings data reliability and data quality, and it's fully compatible with Spark APIs. So if you're using Spark APIs today to process your data lakes, you can convert your data lake into Delta Lake with the run of a single command, and start to benefit from the consistency and reliability of Delta Lakes. Now, a couple of things that I would like to just double click on. So what do we mean by data reliability, right? I mean, data reliability is a bit of a generic term. So if you double click into what is data reliability, Delta Lake gives you full ACID transactions. Okay, I'm not sure if how many of you guys have actually tried to update your data lakes, either because you got a GDPR request to delete somebody's record. It is not easy. You essentially have to read the data and rewrite the whole data, okay, with the one record that you don't want to be rewritten, which is extremely painful. Okay, so you cannot really do any deletes, you cannot do any upserts, you cannot do any merge, and all of that now is fully supported within the Delta Lake environment. So that's ACID transactions for you. Unified streaming and batch. Delta Lake keeps track of what is new data that you have stored within a table, right? Which means that if you need to process the data, you can process the entirety of the data, or you can only process the data that came in the last 5 minutes, or you can process the data that only came since the last time you processed it. So you can do batch applications, and you can do streaming applications all on top of the same Delta Lake. You don't have to create separate pipelines. You don't have to do Lambda architectures. It extremely simplifies your data pipelines. Delta Lake can also do schema enforcement. Delta Lake can also do schema evolution. So you can set a Delta Lake and say you want to enforce a particular schema, and that becomes really helpful as you're moving down your pipeline, as you're taking the data from a raw stage to a finished stage. You start with something that is very flexible, no schema imposed, to a state where you want the schema to be very strongly enforced, right? And Delta Lake gives you that option to do it. You can go from no schema to fixed schema to evolving schema. So if your data has a new element, you can set up your Delta Lake so that the schema automatically evolves with it. Okay, so all of those three features, no schema, evolving schema, and full schema enforcement, is supported within Delta Lake. And finally, time travel. So Delta Lake keeps a journal of all updates and all additions that you're making to your Delta Lake. What that gives you is an ability to recover in case some wrong additions were made, but it also gives you an ability to see what is the state of the world as it was maybe a day back, or as it was maybe 10 minutes back. You can do time travel. You can do infinite time travel and see what was the state of the world as of any previous point in time. Okay, so all of this is now available with Delta Lake, which is really this new standard for creating data lakes. And just to tell you how the adoption of Delta Lake today, 75% of Azure Databricks customers are using Delta Lake as the foundation for their data lakes, right? So they're bringing the raw data and they're putting it into Delta Lake so they can get the consistency and performance that comes off of Delta Lakes. And looks like And just this really quick slide, I'm not going to dive into the details of it. All it's talking about is that with Delta Lake, the reason we are able to do time travel, the reason we are able to give you transactional consistency is because we maintain a journal file. Okay, a journal file really just has information about what files got added as a transaction and or what files got deleted, right? So we can look at the journal file to tell you what files are present at any particular point in time, and allow you to do different kinds of applications on top of it, okay? You want to learn more about Delta Lake, catch me after this session, see us up at the booth, but I want to give some time to my friend over here, Bhavin, who will walk us through a quick demo of Azure Databricks, okay?
All right. All right, let's do it. I'm gonna get rid of this. Okay, is it good? Okay. All right, let's, so what I'm gonna do is, in essence of time, I'm gonna first show you how you can spin up a Databricks workspace within Azure portal. So, this is Azure portal. You come over here and you go and spin up a Databricks workspace. It is integrated with AD out of the box. So those who have used Databricks or created workspaces, you know that there is no additional setup required for authentication. AD integration comes out of the box for you. A workspace is a self-contained instance. So how does that workspace looks like? So I have this demo over here, and what you're seeing is the workspace instance. It is web-based. All you need is a compatible browser. So before I dwell into all this, there are a couple of services that you see over here. Before you start creating any workloads, and this could be data ingestion, preparation, or delivery, it could be related to machine learning, it could be just plain data engineering workloads, or BI visualization. For that, before you start doing any work, you need some sort of compute. That is what you could do it via cluster creation. So cluster creation is a nice UI that sits on top of Azure VM provisioning service. So you come over here, you spin up a cluster on demand, you pick up Spark runtime that also holds our IP. Delta Lake is part of that. So a managed Delta Lake service is available as part of the offering over here. And once you have your compute ready, you want to spin up some notebooks to start, creating some sort of streaming, data engineering, data science, or analytics workload. So this is our notebooks environment. Like you can see, if you happen to be in R, you can go ahead and have a quick R notebook. So you can mix and match. You can pick your poison, whatever language you prefer. What I have over here is a quick notebook that walks you through. This is the one over here. Yeah. So this is like a public data set of Uber taxi within New York City. What you see over here is how Delta Lake can help us with batch as well as streaming workloads, right? So I've got this public data set. We are reading events from Event Hub. So we are ingesting event in a streaming fashion. Delta Lake acts as a streaming source as well as a sink. So think of it like Event Hub in this case is a streaming source, but from Delta Lake table, it can act as a streaming source too. So you can stream records out of Delta Lake to your target sink. So my pipeline over here, it's going to read data at a high level from Event Hub. Once it reads data, it's gonna parse the data stream that's coming in. So whatever events are coming, we're gonna apply our schema, we write it into Delta Lake, and from there we start building our workloads, right? So this is how it looks like, right? What are some of the features that we would like to have? Once I'm reading data, I want to make sure whatever I write, my writes are complete. That means either it is 100% successful or it rolls back. That is number one. Second, every time I make any writes, I want to version control it so that I can time travel. Think of it like you are building some workloads where you want to go back in time. So this is snapshotting, in short. We are just creating snapshots. The third one is small file compaction. Your events could be in let's say sub KBs. It could be 1 KB, it could be under let's say 3, 4, 5 KB. What happens is at ingestion, you want to compact and you want to do it in an automated fashion. You don't want to run any compaction. Why this is important? When Spark shines great, it scales really good when you have larger files to play with. So by default, the read block size is 128 meg. So if you have multiples of 128 meg within Spark, it's gonna scale real good. That is where all the partitioning, all the auto scaling comes into picture. You have Z ordering. We are not using this for this demo, but Z ordering is something that sits on top of partitioning, you use Z ordering for columns that you haven't used for partitioning. And we can talk more about it if you are interested. And the last piece is the time travel that I talked about it. Let me show you a quick, code snippet. So earlier Ajay talked about we support Spark API. So what does it even mean when I say, Delta Lake supports Spark APIs? So those who have worked or built workloads, you must have seen something like this, right? So typically this line over here, okay, I hope it looks better on your side now. This is the Spark API for Delta Lake. Typically this looks like this. Okay, you guys with me? So that's the only change you have to make when you use Delta APIs. This is the only change. You are using Spark structure streaming. You are reading a stream from Event Hub. You are casting the body element or the body tag as a string type. Once you have it in a string type, you just change. Instead of Parquet, you use Delta. What really happens at this stage is you get all the benefits of reliability, scalability, and performance when you tweak this. So I'm going to go back. Then the checkpointing and all is part of Spark structure streaming. So I'm ingesting data at this stage. Once I have data, I want to just do a quick analysis. And you can see this is the body. Now I want to apply schema on top of this body. That is where we come over here and we apply schema on top of it. Once I have schema, Delta Lake would lock it down. That means if any new field comes, you can have a check that just fails the pipeline. That, hey, you have a new field, you're going to corrupt my data lake. So this is the check on the schema enforcement. Once I have my data frame or the clean or the cleansed one, you can see from the raw, this is how it looks. Now I'm ready to run my additional workloads. For example, I can take this stream that's coming in and then massage it, enhance it with some sort of static data that resides in SQL database. So I can have stream to batch joins. Make sense? So that is what Delta Lake can do. It can also do stream to stream join. So imagine you have two different streams and you want to join them, you can do that too over here. So that is what we are doing, and at this stage, Delta Lake acts as a sink. So I'm reading my data and writing it into Delta Lake format. Okay. Once I have it over here, you can run your analytics on top of it. Now, one thing you may have noticed when you build Parquet-based data lakes, if you write any new data, you may have to run a refresh. If you add a new column or a partition column, you may have to run MSCHK check, or you have to update or refresh your partitions. You don't have to do it in Delta Lake because Delta Lake is always up to date. So there is no refresh, no update of the metadata cache because Delta Lake takes care of it. And that is due to what Ajay mentioned, that journal. So Delta Lake doesn't use Hive, it uses its own transaction log. So even like Hive is the bottleneck for most of the Data Lake, based services. Delta Lake uses its own transaction log to fetch out the relevant details. You keep, you go through it. Now you can start, building your workload. So here you can see I'm just running a bit of, analytics on top of it, like how many rides, what are the geolocations, what are the most popular destinations by time and all, right? And then the pickup and drop up. So I'll pause over here. The purpose is not to go through the notebook, but help you get a flavor what Delta Lake is all about. If you have any questions or anything, I'm more than happy to help you out. But yeah, I know it's 7 p.m., so I can do this whole day. I make a living out of it, but I don't know about you guys. So
yeah. It can be on top of regular blob, yeah. The advantage of doing with Azure Data Lake is that you get folder level ACLs, yeah. And if you apply those ACLs at the Azure Data Lake level, then we can honor that within the Databricks environment, right? So the user that logs into Databricks, his authorization tokens can be sent over to the Data Lake, and then depending upon the privileges you have set up at the Data Lake level, the user can get access or not. Right? And that folder level ACL is not possible within a blob environment. Make sense? Yeah? Yeah. Time travel? You want to see time travel? Okay.
I don't think we have in this, but do we have?
I might have a demo of time travel. Just give me a second
I
here.
can show how it works.
So this is a different notebook. In this case, we are looking at some lending data. But if you go down over here, just a little bit more down. Keep going down.
Yeah, this is the one.
Time travel via version numbers. So you can see that with every update that you make to Delta Lake, basically that update has a version number to it, right? And then you can either snap to a version number or you can actually snap to a timestamp. Okay, so this demo is only showing you snapping to a version number, but you can also do a snap to a timestamp. Make sense? Any other questions? Yeah? So does the Databricks need to be running all the time? Did I get that question right? No, so not really. So you can shut down Databricks, right? So the streaming pipeline that we talked about before, that doesn't have to be running all the time. You can shut down your streaming pipeline, right? We will checkpoint the last event that we have processed. And then when you restart that streaming pipeline, like let's say every 30 minutes, it'll begin from the last checkpoint, right? So streaming pipelines doesn't have to be a 24/7 pipeline. Okay, we still recommend for people to do streaming because then it takes care of keeping record of where it stopped and allowing you to restart without for you to have to do all the bookkeeping on your end. Make sense? Yeah? Sorry? 20 minutes timeout for what? Oh, yes. The shutting down of the cluster and restarting the cluster, we have released a new feature called pools. And the pools will allow you to shut down and restart much faster. Okay, and I can talk to you more about pools maybe after this session today. Yeah. CSV files, but not Parquet. So Delta's file format is Parquet, right? So if you convert CSV, some zone in your data lake, which is CSVs, to convert it into Delta Lake, it will get converted into Parquet format transparently for you, right? So you can read from this CSV and write to Delta Lake. Upon write to Delta Lake, it will be in Parquet format, along with the journal file that gives us information about what file got created when.
Yeah, here's that journal file in the background. It is, so we read this journal file and we hand it off to Spark. So imagine you have millions of entries, but this file can be easily passed by Spark because now Spark is handling the metadata side of Delta Lake. That's why it's highly performant. We don't depend upon Hive to provide all these details. Just some low-level stuff. Man.
You'll have to come up. Yeah. So checkpoint, you just have to specify the location of the checkpoint. So yeah, so primary key enforcement is not something that is built into Delta Lake. So checkpointing is not by column, checkpointing is by row number, right? So you don't have to specify anything, right? So Delta Lake, when let's say you're reading from Delta Lake, it will keep track of how many files it has already processed, right? A Delta Lake is essentially a collection of files, right? And when you read from Delta Lake in a streaming fashion, it'll keep track of what is the last file that it has read. So file does not change, right? Only file will get deleted and new file will get added. But the Parquet is not a mutable format, right? So we will keep creating new files. keep creating small new files that we will then merge to create bigger files. You don't have to do anything. It's all completely taken care of by Delta Lake in the background. It'll keep track of that.
It keeps track of the offsets. So file would have an offset. Yeah, so this, it's gone again. You have to sign in. But the transaction log, it's a JSON file, and it has the offset number. So it's incremental, right? It's like a 16-digit, numeric key. I think more than that, 32 or like that. It keeps adding like 0001, 0002. We can sort out easily, right, that column. So we will pick the last one, and that would have all the details. What files were added, what is removed, add and remove. These are the two activities that it would have.
Delta Lake is only for data that is sitting within your blob store or ADLS.
Yeah.
Mm-hmm. Yeah. With new Synapse. So Synapse is also now embracing this idea of data lakes, right? So Synapse is coming from the persona of a data warehouse user, right? And sometimes so typically what we see our customers do is they will land all their enterprise data into a Delta Lake, yeah? And then they will take a subset of that data, right? Maybe what is the refined data, and move it into their data warehouse, yeah? Now, in a traditional environment now, as a data warehouse user, you would only be able to query what has been moved into the data warehouse. Yeah? With Synapse, now Synapse is enabling you to actually query the entirety of Delta Lake, if need be. So it's addressing the need of the analyst to be able to query the data that's sitting within the data warehouse, but also data that is sitting outside of the data warehouse. Yeah, so it's really coming from the persona of the data analyst, from a BI persona, and expanding the amount of data that they can query. Okay? Databricks is coming from the persona of the data engineer and the data scientist, right? That's the user community that we focus to. And we continue to enable the data engineering and the data science workloads within our environment, right? So our customers are essentially Spark first, data engineering and data science first customers. Synapse customers are BI and reporting first customers. Yeah.
The question could also be, why do you need data warehouse if you have Delta Lake? Right? You have schema enforcement, you have
Yeah, so that's a really valid question. I would say till date, right, the concurrency throughput of data warehouse is higher than Delta Lake, right? So if you have thousands of users who want to run millisecond queries, you are much better off doing that on data warehouse than doing it on Delta Lakes. Yeah?
What is the plan for wider support of Delta Lake in terms of the Microsoft platform? So Data Factory, Power BI, and so on and so on.
Yeah, good question. So what's the plan for extending the support for Delta Lake across other Microsoft ecosystem? So Azure Data Factory, we are actually working with the Azure Data Factory right now as we speak. So I am working personally with them, so I know that that's coming. Synapse, we are having a discussion with Synapse PM teams to support Delta Lakes directly. Yeah, so that's a discussion ongoing. The actual engineering has not yet quite commenced there. And Power BI connects to Databricks over JDBC ODBC, right? So there you don't need a direct support for Delta Lake because you're going to come through the Spark SQL that is available within Azure Databricks. You do need, yeah. Okay, any final questions? It looks like not. Thank you, guys. Again, if you have questions, I'm available over here after the session. I'm going to be available at the booth, me and Bhavin both. Please come seek us. All right? Thanks again.